Okay, so now we're going to talk about the conduction system of the heart. So, like the mechanical part of the heart, the mechanical system of circulation, there's parts and a path to your conduction system. So, one of the unique things about the heart is it has its own pacemaker. It's found in the atria. It's in the top right hand side of the heart in the atria, and it sets the pace for the heart. Now, the pace of the heart is affected by different things. It's controlled by the endocrine system and the nervous system. So, if you're you're walking into a room and somebody jumps out at you and goes, boo, you're startled. Okay. And that stimulates your fight or flight, which is your sympathetic nervous system. Your heart starts beating faster, your breathing starts, your eyes dilate, your muscles start to fill with blood. That's your sympathetic reaction. It's the fight or flight response, and your heart beats faster, right? Because you're scared, and your sympathetic nervous system is saying, "Hey, we need more blood because we're going to have to either fight or run." So once that fright is over and you realize it was somebody that was, just being funny, your parasympathetic system takes over and it starts to slow everything down. So your sympathetic nervous system speeds everything up and your parasympathetic system slows everything down. Now, the sinoatrial node, that's the pacemaker we just talked about. It's called the SA node. It's found between the opening of your superior vena cava and your right atria. Okay. It sends out an electrical impulse that regulates your heartbeat. Okay. It regulates your heart. The impulse that it sends out goes over the atria and it makes them depolarize and contract. Okay. And this causes blood to leave the atria and go into the ventricles. Okay. Now, once that leaves the SA node, that impulse leaves the SA node, it gets to just about, the middle of the heart. And it's a group of cells that are between the atria and the ventricle and the septum. Okay. The AV node, or the atrioventricular node, slows the roll. Okay. Atria tend to beat very quickly. The AV node slows the roll, and that impulse goes through the AV node into the bundle of His, and that divides into right and left branches. And those branches, that impulse goes through these very fine fibers, goes through the bundle of His into the Purkinje fibers. Okay. The Purkinje fibers are all over the heart and the ventricle, and that's what stimulates the ventricle to contract. So the SA node sends out the impulse, the AV node slows the roll, slows down that impulse, and then it goes through the bundle of His into the Purkinje fibers, and the ventricles contract. Ventricles contract. Now, we can tell what a heart is doing electrically by putting a person on an EKG. So if you have an EKG on, you have these little electrode pads that have wires attached, and it takes a picture of the electrical activity of your heart. Okay. This is so they can see if anything is wrong with the electrical system of your heart. Systole is when your heart contracts, and diastole is when it relaxes. Okay. That's how it's defined. Okay. Now, the cardiac cycle. Let's go through that because you can see it. Okay. You have the SA node send out a electrical impulse. When the atria depolarize, okay, that's your P wave. Okay. And then that electric impulse goes through the AV node. Okay. And when it goes through the AV node, it goes through the bundle of His to the Purkinje fibers, and your ventricles contract. Okay. When your SA node sends out the signal, the electric impulse, the atria are depolarized and the ventricles are relaxed. Then, when that goes through, the impulse goes through the AV node, it slows down, goes through the bundle of His to the Purkinje fibers, the ventricles contract and the atria relax. Okay. The tricuspid and bicuspid valves, or bicuspid or mitral valve, are closed when the atria relaxes. You need ventricular depolarization for the ventricles to contract. And when the ventricles contract, they push that blood through the semilunar valves. On the right, it's the pulmonary artery semilunar valve. On the left, it's the aortic semilunar valve. And then when those ventricles repolarize, the semilunar valves are closed. So atrial depolarization happens when the SA node sends out an impulse. As it goes through it goes through the AV node to the bundle of His, through the Purkinje fibers, and you have ventricular contraction. That is Q, R, and S. Okay. And then ventricle repolarization or relaxation happens, and that's the T wave. Now, the reason we can't see atrial repolarization is because the ventricles are contracting, so that gets lost in that QRS. But the atria in the heart do repolarize. Okay, it takes approximately zero 0.8 seconds for a complete cycle. Okay, and you can see how that works here. So the P wave is the atria depolarization. Okay, and they squeeze the blood through the um, tricuspid valve on the right and the mitral valve on the left. Then you have that electrical conduction go through the bundle of His into the Purkinje fibers. That stimulates the contraction of the ventricle, which is the QRS, and the mitral valve and the tricuspid valve close. The semilunar valves open. On the right side, the pulmonary semilunar valve opens and goes, the blood is sent to the heart. On the left side, the aortic semilunar valve opens and the blood is sent to the rest of the body. Okay. When the ventricles repolarize, they relax, and that's your T wave. Okay. Here's a diagram that I put here just to help you guys out and show you what you're looking at. Okay. Conduction starts in the SA node, then through the AV node, through the bundle of His right here, which I forgot to put an arrow there, but that's the bundle of His, and then through the Purkinje fibers, which stimulate the contraction. And that's a normal sinus rhythm. So when you do an EKG, I do a 5 lead, but like Miss Spears, she might do a 12 lead. She knows how to read a 12 lead. I do not, because nurses don't need to know how to do that unless you're in advanced practice. But it gets that, it can show us what that electrical activity is. Okay. Here's your PQRST. So you have a baseline, okay, and that is no current. So say there's no current flowing. Then you have positive deflection. That's when the SA node sends out the impulse and it travels down the heart. The negative deflection is when the impulse travels back up the heart. So the P wave is atrial depolarization, the QRS is ventricular depolarization, and the T wave is ventricular repolarization. We can tell whose heart is working right just by looking at this. Okay? Just by looking at this. I'm going to show you some different uh, heart heart rhythms in the next lesson. I did go over my 9-minute max, but not too far over. So I'll see you in the next one.